And today we are very excited to have Angel Anderson from FutureDial, who is our guest speaker for today. And she is going to speak to us on the cost of quality. All right. Thomas, you want to introduce yourself and your company right quick? Just a little brief introduction.
Sure. Thomas Reyes with FutureDial. Angel's on my team. She'll be doing the presentation today. We are a software company in the mobility space, really targeted at reverse logistics, hardware, software, and process automation for mobile devices.
Okay, and I think Angel's going to give us a great overview here in just a minute. All right. Well, why don't we go ahead and get started then? Angel, I'm going to bring up your presentation, and you just tell me when to advance the slides. All right, you're on, my dear.
All right. Well, first off, thanks everybody for joining, and thanks for having us to have this discussion. We look forward to it, and we hope that you have some good takeaways from this. So today, as mentioned, my name is Angel Anderson, and I'm the Product Solutions Manager at FutureDial Incorporated. And today we're going to talk about the cost of quality and how robotics are really revolutionizing this space. So if we can go to the next slide. So just a little bit about FutureDial. We provide software and hardware solutions for the wireless device process. So we work in the forward logistics space and the reverse logistics space, offering services such as device identification, valuation, testing, consumer content removal, provisioning, and some other processing solutions. So for today's discussion, we're going to be focusing on the reverse logistics space, where cellular devices are collected from the end consumer and come back through the process for testing, processing before they go to that secondary market. Just a little bit about my background. I've been in the reverse space for 15 years. I worked for a company named PTS Electronics, which was later acquired by Motuslink. It started out as a job during college as a line operator. So I performed various tasks from data entry up to level 3 board repair. I then moved up as production team leader and then up to production supervisor, and then moved over to the planning and procurement manager. And at that point, I was responsible for planning and procuring parts, most of which had a minimum 6-week lead time. And this is where I learned to forecast. So not only did I have to, predict how many of a model was going to come in 6 weeks or further in advance, but I also needed to know the color variant. So that was back when pretty much every model had at least 6 different colors. We saw it actually go away in the market for a while, and Apple's brought it back, but very important. So that gave me a new perspective on the operation. Something else I had to do at that point is watch the attach rates, or how often operators were using parts, and then flag operations if they were out of spec. Now, having been an operator myself, I realized it was a lot easier just to put on a new housing and not risk getting a quality failure. But now, as a planning and procurement manager, I understood that mentality could run us out of parts and even potentially shut down the entire operation. So it was a nice flip side of the coin there perspective. Ultimately, I ended up in client management, and I helped launch the Sprint, the AT&T, and the Verizon trade-in programs from the beginning. And that gave me yet an even wider perspective of how all those little pieces fit together. So I've since been with FutureDial for 3 years now, and I use all that experience to assist in product design to make sure our solutions really fit our customers, as well as I consult with our customers to find the best fit solutions for their business requirements. And now with FutureDial's new robotics fleet launching, I've been tasked with helping prospective customers to measure the ROI, which really led us to today's discussion on the cost of quality. Next slide. So specifically, we want to focus in on the fully automated robotic solutions and how they affect this business segment. So the forward logistics, or the manufacturing side, has employed robots for decades. And that business has a very repetitive nature with a single model coming off the line. The brand new parts have really high quality, and so robotics were a reality early on. But the reverse space is far more complex. And so this supply chain, it can collect a mix of 4,000 or more models at any given moment. Pretty much every model that's ever been on the market could come back for these processors. And these are used devices with varying degrees of wear and defect. A good portion of them people surrender because it has a problem with it. So due to these complexities, robots in the space have only recently become a reality. And what I'm finding during these ROI discussions with the customers is they sometimes get tunnel vision and they focus on the direct labor at the physical point where the robots are deployed. So if you have a human being doing a task today and you replace them with a robot, they look at that direct labor and that's what they're putting on their ROI. But they're not really considering where that exact same robot is affecting other points in the process. Now, it goes to stand to say that there's, a proportional amount of overhead for that one operator, such as, management, HR resources, parking spaces, indirect costs that are appropriate. And those are easy discussions to have, but what's more difficult is trying to measure the effect that that same robot has on inventory and quality. So if you recall my example of how an operator changing too many parts can increase the investment cost or even run, an operation out of parts, now imagine the impact of a robot making that decision, because we remove the subjective nature and we get a very consistent objective point in the process. What we're going to talk about today, we're going to focus in on the quality portion of what that robot's affecting. And this is one of the challenging conversations to have, because quality, as it stands physically in our process, is so ingrained in us, it's sometimes hard for customers to take a step back and understand why it became that way. And so we're going to really look at that today. Next slide. So the cost of quality can be a very broad conversation, and it varies drastically from operation to operation. So let's set the stage a bit and pinpoint exactly what we want to measure in today's discussion. And specifically, we're going to be talking cell phones. And to do that, it might help to understand what FutureDial's customers do, since they're the organizations that collect and process these devices and then ultimately distribute them. So our customers, as we mentioned, we do forward and reverse space as well. In this segment, they collect devices from the primary customer, whether that's warranty returns or trade-ins. They identify the device, what it is, they visually inspect the condition, they functionally test or triage, remove customer content. Some of them do value-added services such as cleaning, refurbishing, or repair, typically assign some type of a grade to the device, and then they sell or distribute it downstream. And now that may be going back into warranty seed stock, or that may be going into the secondary market, either through business-to-business or business-to-customer channels. Now that's still a pretty broad view of the supply chain. So if we go to the next slide, we're going to drill down a little bit further and look at specific tasks. So everybody's process is a little bit different, but if you get to the root of it, everybody has to do the same things to these devices. So one of which is identifying the device. And that's not just unique identifiers, such as the IMEI. That's the make, the model, the memory size, the carrier, all of that information, all of the attributes. It needs to have some type of visual inspection, and the level of these testing can vary, and we'll get into that a little bit, but scratches, cracks, broken pieces, missing buttons, that type of thing. It needs to have some kind of functional condition assessment. So basic functions, minor functions, again, variable testing, but we need to know if the device works. The customer content has to be removed or the device has to be destroyed. And then eventually, all of the criteria in those orange boxes roll up into some form of a grade classification that tells wherever this device is going what the overall condition is. And those affect the asset value, whether that's a seed stock qualification or an actual resale value. Now, why are those things important? So if you look at the bottom line here, what we've done is we went online to some distributors or some online sales channels, and we just pulled some very specific examples of how the value of a device is affected by these. So the first one we see is that for a certified Apple iPhone X AT&T, same condition visually and functionally, the difference in memory size from 64 to 256 is $70 in list price. For the next one, the visual inspection, again, the device is the same make, model, and memory size, but you can see by moderate wear, minimal wear, or like new, there's a pretty big swing, $20 to $50, on what the value of that device is. Now, that's just one device. When you multiply that across millions, that number becomes pretty substantial. Consumer content, I think we're all aware, is a huge risk in this business. And so if a device is not cleared, so it contains consumer data, there's a very small arena of downstream channels those can go. Basically, they have to go to somebody who's certified to responsibly remove that data or to destroy the device. This last one here is a refurbished lot of iPhone 8. So for the grade A lot, the average price per device was $749, for grade B, $719, and for the non-functional, it averaged $419 per device. So again, just the grading structure itself on how all those classify go into affecting that asset value. And the accuracy of these today depends on human beings. And we're going to discuss that concept a little bit more here in a minute. Let's dig into the quality side of things since we've kind of narrowed down the exact process that we want to look at and measure today. Let's start talking about quality. And on the next slide, we're going to see how the cost of quality is defined. Now, if you type this into Google, it's going to return you a definition as a methodology. Basically, what organizations use to determine the extent of resources in identifying or preventing poor quality, as well as identifying the value of an organization's product. So in short, how much time and money are we willing to spend to achieve X? And what is X? Is that creating that definition of what X is. Now, while this is a methodology and we're going to analyze it as that aspect, this is also, there is a tangible cost to the cost of quality. So we're going to talk about both of those in this presentation today. Next slide. Oh, you're right on it. Okay, so when determining the expectations of quality for the final product, first there are compliance requirements that must be met. So these can come from SLAs, regulations, governance, standards, etc. And typically these are non-negotiable. So if we were working from a blank slate, these would be the minimum quality requirement for our operation. Next slide. So because these processes up until now have been heavily dependent on humans, the cost of quality has drastically been affected by human error and human labor. So we're going to cover both of these as well as how they affect each other and then the effects and impacts they've had on asset value. And to understand how robotics and automation have revolutionized this concept, we have to first understand the obstacles that exist today and how they got there. Next slide. So first, let's look at human error. We all know this is a reality. We know we make mistakes, but we often miss how much time and cost has actually been built into a process to accommodate this. Human error creates risk. The measure of risk greatly depends on the specific function and the exposure. So for example, minimal functions such as a gyroscope selling into a bulk refurbishing market may be measured as a minimal risk, while consumer content being sold to an end user, that's catastrophic. So who are the people that touch these devices? If we look at human nature, it's often overlooked when we're crunching numbers into a spreadsheet. And the fact is these are real people with real world problems. I mean, they have good days, they have bad days, they come into work sick, they have a lot going on in their minds, and they make mistakes. And we know that on some level, but sometimes we forget to humanize what's really tangibly, physically happening in our operation. These guys, their average wage is about $17,000 to $24,000 a year. And a lot of these are staffed through temp agencies. They perform repetitive tasks over and over all day long, every day, every week. And so they're real people, they're going to make mistakes. For the typical industry processing, a device identification operator is going to process about 2,000 devices a week. A visual inspector will process about 3,200, a functional tester about 600, and a data clear operator with software assistance about 2,400. So that's a lot of devices. And so I ask you, if you were given a task to do to 2,000 devices, are you sure you could get it correct 100% of the time on every device? Next slide. The answer is no. Statistically, you would make 140 mistakes on those 2,000 devices. Now, that's assuming you're working in an ISO 9001 QMS process. If your process is not ISO 9001 compliant, you'll actually make more errors. Studies have suggested that the human error rate with these stable, well-documented processes is around 7%. So that means out of every 100 phones, an operator will make 7 mistakes. Now, that impact can vary based on the operator's responsibility. Again, if it's a minor function with low risk, it may not seem astounding. But if it's a data breach and we say an operator is going to make 7 of those for every 100 devices, that's really alarming. So if we take that same chart that we just looked at on how many devices the average operator processes, we can now calculate in red what that 7% equivalent is. So we see that the data clear operator who processes 2,400 devices likely is making 168 mistakes. And that's scary, right? But it's a reality in the process. Next slide. So because it's a reality, we've had to build constraints around it in the process. And this has forced operations to build additional costs in to attempt to catch and correct the human error. But the challenge is these are also human beings who are going to err on a 7% margin. So ultimately, the concept plays a statistics game that 3 people will not err on the same 7% of devices. So this visual example shows us the initial operator that's performing their task, and then most operations employ a 100% QC behind that, and then some form of quality sampling behind that. And the statistics game here is hoping that these quality operators catch the mistakes of the first person. Now, if these quality people do 100% of the tests, so if they test everything that the initial operator did, it more than doubles the labor cost. And in this example, it would cost $2.09 based on a loaded $15 an hour labor rate, just in quality checks. That doesn't include the initial inspection. So the cost of quality in this model, just to catch the errors, would be $2.09 per device. This is actually cost prohibitive in most operations. So if we go to the next slide, we'll see more indicative of what operations do today, and that's called targeted quality testing. So what they do is they measure the risk, and they say that they're willing, based off of the statistics of failure percentages and then where the device is going, that maybe they're not as worried if a button slips through in error, but they're definitely worried if customer content does. So what they do then is they modify or reduce what the quality people are testing for. In this example, the quality operator, the 100% quality operator, they're sampling the model identification, only checking it on a certain percentage of devices. They're not worried about scratches or cracks on the visual inspection. They're performing the basic functions of the device. Does it power on? Does the touch screen work, etc. And then they're checking 100% for data clear. And then the sampling operator is just sampling, but the devices they sample, they're checking those for data clear. So this is more closer to what you would see in a typical trade-in operation, if you will. Now, the caveat here is that they're knowingly allowing room for quality to escape the process, quality failures. And the caveat there is that it can actually reduce the revenue. And we'll touch more on that in a minute. But the takeaway here is that these steps, even though we've reduced that on this slide to 52 cents of a cost to find those errors, it's still built in to catch the human error. And that's why they exist today. So what happens to those errors that they catch? If we go to the next slide, we're going to see some numbers here. So hopefully our redundant quality inspections have won the statistics game and caught all of the human error before it escaped the process. So what happens to the failures that they catch? And the reality is those have to be reworked. We did a recent study with one of our partners, and what the results produced is that for every device that failed quality and had to go back and be fixed and come back to a quality state, it incurred an average of $1.80 per device to handle that. So on top of the value of catching the errors, for a 2 million device operation, that's $252,000 in labor to fix the problems on top of what it costs to catch them in the first place. So we can see that the human error has just built in so much cost. If we go to the next slide, we'll just see a high-level summary. We're going to put those two numbers together. And based off of this data, we can put a tangible cost to human error. And what we're estimating here is for every 1 million devices processed, we're looking at about 2.3 million to 3.8 million, depending on the level of quality testing, in labor. And that's really huge considering it was built into the process just because of human error. So when we're looking at the ROI, most operations are really not looking to the quality cost that could be reduced by eliminating this human error. And since robotics removes the human error element, they can also eliminate this enormous price tag that was actually created by human error. All right, let's go on and talk beyond compliance for a minute. So up to this point, we've discussed the minimum quality level to meet compliance. And if you're a 3PL, your SLA has likely already covered this next section. However, it's important to understand what your customer considered when defining the SLA for their product. And you may have actually had a hand in this through pricing negotiations, or you may have just received an SLA and you just priced to meet demand. But I think it's important with what's up and coming with robotics and the improvements to open up those discussions with your customer. So if we look at the human labor, the value add versus cost, in human operations, every test or inspection performed will add to the investment cost because of human labor. Every second that your operator is clocked into the time clock is incurring cost. So any additional testing is going to add to that price. And organizations have to determine what level of testing is optimal to return on that labor value. So these decisions are greatly impacted by the cost of human labor, which is your investment cost, against the value return on the asset. And specifically, how much more will the secondary market pay for a device that has been tested fully, so like an NFC function, for instance, or what about a gyroscope? And based on marginal failure statistics, does an accelerometer fail often enough to pay extra to have every device tested, or does the secondary market gain more by assuming the risk that maybe an untested accelerometer is only going to fail maybe less than 1% on devices? And as you can see, the decision of what to test has been driven by the labor cost required to do so, which has actually created another monster in the secondary market. Because organizations have been independently making these decisions, there's not a widely accepted grading criteria. And so while the naming logic of A, B, and C are popular, the actual definition of what qualifies in those grade categories is inconsistent between sellers. Now, R2 is kind of the first standard that actually defines specific functions required, but a challenge here is that not a lot of organizations adhere to that today. On the next slide, we're going to see a snapshot of the ABCD from CTIA, and they're making great strides in creating a documented standard for grading, and they've really teamed up with some major players to spearhead this effort. Now, they've taken a very extensive approach of classifying not only A, B, C, D, and E, but they've also added classification levels for both cosmetic and functional conditions. And this really highlights the wide variation of testing performed in the market by the rather expensive nature that CTI has taken to accommodate that variability. So essentially, they've designed their grading criteria in a manner that it doesn't force operations to perform more tests than they do today. Instead, their approach has standardized the naming logic that can accommodate those specific classifications so that the secondary market has a clearer understanding of the product condition, both testing and lack of testing, before they buy. As you can see in this screenshot, they get very specific with listing the types of, this is actually cosmetic, so the types of cosmetic defects, the size, the measure, the count, and even what's allowed on specific surfaces. If we go to the next slide, we'll see the classifications for the functional testing. There's actually 10 levels of functional testing, 0 through 9, 9 being not tested. And they do break out what classifies as a major and a minor. The next slide gives you a little bit more detail on that as far as what they consider in their grading. Now, what's interesting here is you'll notice that not all possible device functions are listed here. For example, accelerometer, magnetometer, and gyroscope are a few. This is further challenging because not all the devices contain the same technology. For example, in today's market, not all devices out there have NFC capability at this time. And so requiring a function that doesn't exist on all models is prohibitive to grading standards. So this still leaves it to the processor to determine what to test, right? What additional testing. And the challenge lies with those defining this grading standard on when and if to even add a new function to the major minor functional category. So in short, these standards along with the testing requirements, they're always changing. And that can be a major learning curve to a human being, especially when that means knowing when and if to test something on only percentage of devices. So again, you as an operator, if you could receive one of 4,000 different models, and you're processing, 2,000 a week, would you know which ones have NFC and when to test it? Very costly, and the training and the uptime can take months for an operator to become proficient in that. And by that point, things have changed again. And this is another opportunity for robotics, because with robotics, it knows which models have which functions and when to test. And so adding a new function is as simple as flipping a switch. You just change the profile, upload, and it's instant and consistent in an operation. Just to get a little bit of perspective, this next slide has a snapshot of FutureDial's functional test planner for the Apple, and you can see there's over 70 test options on here, which is quite a bit more than what we just saw listed on the previous screen. Now, I will note that some of these are tests that test the same function but in a different way. And again, it goes with that market variability. As new features and functions come out that increase the testing labor, sometimes customers are changing the way they want to test previous tests just to try and mitigate some of that labor cost. If we go to the next slide, we can see just kind of a high-level snapshot of two functions on the phone and how they've changed over time. So if we look at the evolution of display, back in the day, it was really display only, which moved to touch screen, and then we came out with multi-touch advancements and pressure sensors, and I'm sure we'll continue to find new features being created, and even how the cell phone communicates itself. So originally these were call only, and then data became a feature, and then GPS capability, and now NFC. So even the way the phone communicates, there's constantly new technologies coming out, and I don't see that changing anytime soon. So again, it adds more variability and complexity to what we've been asking these poor human beings to handle all this time. So let's put some numbers to the labor. We talked about the labor, but what does that really equate to? So on this next slide, we're going to look at, again, using that $15 per hour loaded burdened labor rate. We did a time study with one of our partners, and what we found is that for an operator to do the 19 most common tests in the trade-in industry, if they had to manually invoke the functions, such as using native apps like voice recorder or the camera app to invoke these things, it costs about $1.73 per device for them to do those 19 tests. Now, if we took that same operator and then they use some type of third-party software like FutureDial's functional test app, where it interacts with the operator, prompts them when and where to touch the screen, for instance, and then automatically detects whether or not it sensed that movement, it did reduce the labor down to $1. But you can imagine, if that's only 19 tests, what would that cost if we tested 30 of the functions or 50 of the functions on the device? It starts to become very astronomical. And so we can understand now why this reduced number of tests and expectations into the secondary market was created. Now, the benefit here is we took that same operator and we put them managing 6 of our functional test robots, and the labor cost dropped down to 15 cents per device. Now, the caveat here is if we want to test 30, 40, 50 tests, that would not increase the labor cost. It would just increase the number of robots that one operator could manage. And of course, then there's the next step. You could go full automation with robotic arms and remove that element altogether. Now, remember, this is the cost for the first inspection. This does not include the quality checks behind it to try and catch those errors. And again, if quality is checking every function, it's going to more than double the labor. And even if they're only checking a partial function, it still has significant impact. So what this has done is it has inadvertently created a monster into the secondary market, and it's actually defined the world as the secondary market knows it today. If we go to the next slide, the secondary market, especially the bulk market specifically, they've only ever known a conflicting definition of what grade A, B, and C means. And they're accustomed to getting mixed lots of devices that contain failures, some of which may be human error that escaped the process, or some of which may be deferred testing that just wasn't economical to test those functions. They don't typically see bulk lots where every function that exists on a device was tested. So in short, the secondary buyers, they're assuming the risk when they buy these mixed lots. And as a result, the secondary market pricing reflects these obstacles. On the next slide, we actually had a downstream purchaser confide that he discounts his purchase price by 15% to accommodate the risk. So he did the study on the lots he was buying, the number of devices that he was finding issues with, and that's the number that he came up with, was discounting that purchase price by 15%. So what this means is for every $1 million sold to this buyer, the seller missed out on $150,000 in revenue. Now, in fairness, the cost of quality decision that drove their process decision most likely determined that the human labor cost to meet that standard was actually greater than the $150K return. So this is another obstacle that robotics can remove. But what if robotic automation takes away the human error factor? If we go to the next slide, we're going to crunch some numbers on this. If we can take away the human error factor, take away the human labor factor, allowing us to perform more tests, and standardize the consistent grading. If we just look at FutureDial customers for 2018,
they processed around 40 million devices.
Now let's assume all of those were the trade-in market. They weren't, but we want to be conservative here and use $300 per device for the good, bad, and ugly. That's the newest models, the oldest models, etc.
That would be a $12 billion revenue stream right there. So if we look at that 15% opportunity, that's $1.8 billion.
So if all of the buyers that purchased these devices downstream discounted them 15%,
that's $1.8 billion of lost revenue.
That's quite a bit, right? So admittedly, as a former 3PL, I understand that in that space where we didn't own the product, we didn't even really have visibility to the resale value, we typically kind of skimmed over these conversations. But I think it's important, especially today with what's coming, that 3PLs really started to have this conversation with their customers. Because with revenue potentials this substantial, it opens up the conversation with the 3PL and their customer to partner in moving to automation. That may be an agreement to help with investment costs. That might be some agreement with profit sharing on some of this returned revenue. Or it may even just be adjusting contract terms to ensure that the time and volume can meet the ROI for the 3PL. Quite honestly, as a former customer manager, sitting down with my customer and showing them that they could potentially return $45 million for every 1 million devices would have been an easy conversation to start. And it can make the customers very happy. So in summary, let's just kind of sum up all those numbers. I know I threw a lot at you. So quality steps and process have become a staple, if you will, and something that most organizations think is scandalous to even consider eliminating. I got to tell you, if I'd went to the operations manager and told him I was thinking about taking out QC, he would have had a heart attack, because it's just something we've always done, and it's very, very important we understand that, but we forget why it was created. And we have to remember that it was created because of human error. And thus, the cost for quality was increased to accommodate that human challenge. See, the redundant quality checks were not put in place to fix the root of the problem. You can't make a human being perfect, but instead they were a contingency to stop the bleeding. Now, once robotics are deployed and the quality testing proves their accuracy, organizations are going to be able to remove these redundant steps, which has huge gains not only in cost but also turnaround time. So we've also eliminated the 7% error rate. So since the machine's not making those 7% errors, we've reduced that double handling of the devices that we had to catch in the first place. So all in, as you can recall, if we add all these together, we were at about $2.3 million to $3.8 million per 1 million devices processed in this cost, which is a huge price tag. And then we talked about the consistent quality. So the ability to remove the process error escapes and to perform better testing. And that 15% discount on the next slide, if you recall, it was $45 million for 1 million devices. Now, we also talked about more testing. So the secondary market has only ever known a reality where the basic functions, minor and major, were ever tested, but they've never known a market where all of the functions were tested. So the question becomes, how is that going to impact the downstream sales, since they're no longer assuming that liability? And it's really, quite honestly, it's impossible to even project what we think that could be. But what we can measure is what 1% lift of value would be.
And if we look at that $12 billion market example that we just experienced, that's a potential for $120 million in increased revenue potential just for a 1% lift on resale value.
So if you want to do the mental math for your organization, that's about $3 million more revenue for every 1 million devices. And at 1%, I think that leaves a huge ceiling for improvement. I think we're going to see some really big gains on this in the future. And with numbers like that, I mean, we're sure to see positive impacts in this arena, whether you own the product or your customer does. So on the last slide, we just kind of put all these together. If you recall, we talked about, the ROI has the direct labor, indirect labor, and inventory. Those are discussions for another day. But just in that quality bucket, we measured a huge, substantial opportunity for return on investment in this. And we really kind of dug into why the process is the way it is today, and how then why robotics would be eliminating some of those obstacles. So at this point, let's just open it up for questions.
This is Alex from PCS. Angel, that was really, really interesting and incredibly deep, and also with a lot of breadth. So thank you for that. That was really, really interesting. I'm curious, you mentioned about obviously it's all about consistency and quality consistency with the robotics and the reduction of the human interaction. What's your estimated sort of finalized estimation on time, I guess, for having sort of a clear understanding of that quality, where you're getting that consistency from the robotics? Because I know it's also based on, how many you're processing and just continue that AI learning. What's your expectation of time to have something where you feel really confident that, obviously always continuing to learn, but where you feel you're at a consistent quality?
Do you mean within the processing steps, the consistent quality on the device, or do you mean the impacts into the secondary market as the upstream market adapts this?
No, I think that the upstream market will adapt as that happens. I'm just saying the quality confidence. I mean, I know that it's a machine learning thing, right? As you're looking at the different kinds of robotics and automation based on diagnostic, which is to a certain extent pretty clear, but then, also looking at the grading, sort of a little maybe more learning involved. Where are you guys in the process feeling confident of your quality that's coming out, where it's super consistent, there aren't any errors, there's no more necessary learning, it's all just going to be, cherry from here?
Okay, great question. Thank you for that. So that's actually really impactful to talk about. So for the functional testing, FutureDial has launched the RADI last year, and we have quite a few customers who have been running this for a significant amount of time. What we're finding with that is that the way that it was designed is already allowing for that consistent quality. And what I mean by that is it was designed in a way that's easily configurable to the customer. So they set specific limits, whether that's the audio, the video, the screen, the camera. And I actually personally witnessed this with a potential customer 2 weeks ago, where they were adjusting those limits and achieving the exact quality that they wanted. So from a software and hardware perspective, the functional testing aspect is there today. It's really a matter of dialing into what a specific customer's business segment defines as acceptable. We are following the CTIA guidelines very closely so that our products will already have that defaulted, but because of the variability in the market today, the reality is everybody, wants their testing just a little bit different on limits. Now, the visual inspection and grading side, so we anticipate in about mid-April really kind of launching a go-to-market demo for that. So that is the latest and greatest. As far as our production models, our demo model that we have right now, again, we kind of took this logic where it's not AI learning, so it doesn't take it time to learn what is acceptable and what's not. It looks at the defects, it counts them, it measures them, it logs them on a surface, and it's set up in a way that the customer can create a profile or use the CTIA profile, which we'll have preloaded, that says, okay, this has X defects with this size on this surface, and therefore it qualifies as an A, or maybe this one's a B. So that it takes away that learning time. As far as the go-to-market with that, I think probably mid this year, you're going to start seeing that more in production processes.
That's really cool. That customer-created profile, I think, makes a lot of sense as, you know, to your point of the downstream into secondary markets and as these things are adopted. So it's very cool. Thank you.
Thank you.
Any other questions?
Yeah, hey Angel, this is Chris Blease from Service Central, and I'm very familiar with your guys' product. I just had a question on the numbers and the calculations that you had in here. I think you said $2 million to $2.3 million in additional cost. Is that additional cost above what you've quoted? Is that looking at it from what was quoted in price, so additional cost in quality checks?
Yes, so that is all direct labor at this point. That doesn't include any of the investment costs. So this was measuring what does it cost for an operator to perform these functions in the process today, whether it be the initial inspection, which we looked at, but specifically the QC operator or the QA operator sampling behind them. And then we did look at, for the devices that fail, they do have to go back to that primary operator, and so those were $1.80 each at a 7% failure rate. Does that answer your question?
Yeah, no, that's perfect. And then when you looked at what the savings would be by running robotics, did you calculate that on 100%, or I'm sure there's, you know, you did a gauge R&R and you're expecting 99% accuracy or 99.9% accuracy. Did you use any percentage there, or was it just strictly 100% accuracy?
No, at this point it is just 100% accuracy. So the way I see this going, I'm a very skeptical person and I'm a bit of a data snob myself. So I kind of put this as the raw numbers. So here is what the operation is today, right? And what I would assume, or what I would do as the customer, is once I employ these robotics, I would not immediately remove my QC just because I'm that skeptical person, but I would measure and test that quality behind it. And that's what I think most organizations are going to do. They're going to really test these robots. But the data, I'm confident, is going to show them that, you know, based off these percentages, the accuracy is here, and so we can make appropriate movements. So this is kind of like what you could save, maximum best case, and then your results and your operation definitely would then come off of that.
Yeah, and you know, I'll have to say that, you know, looking at and seeing your guys' robotics and some others that are in the industry, you guys have made some huge strides, and very impressed with what you've come up with, and you know, the ongoing development and things that you're putting into it. So great presentation.
Well, thank you. We appreciate that.
I have one more question. It's Alex again from PCS, and I think it sort of dovetails onto what he was just saying, is that obviously everybody in the industry is looking at robotics and automation for exactly the reasons that you're mentioning, you know, having to do with grading. I mean, the CTI grading standard is sort of an indication that everybody's aware that this is happening, and the robotics and automation is obviously an important piece to ensuring those kind of things. You know, at PCS, we've been looking at these for a long time as well. I mean, I think it makes a lot of sense in terms of how you've presented it. I'm wondering how you guys see yourselves as being different than what else is on market. I mean, how do you sort of differentiate your offerings? I mean, clearly the grading robot is a next level, but just in general, how do you see this as a differentiator?
Yeah, that's a great question. I would say the approach, and one of the differences, one of the main differentiators for FutureDial is their team. Myself came from the operations. Several of our management staff have come from the operations, so they really pulled people into our team that had lived the process and breathed the process to help with the product development. So first off, we understand the customer. Some of us have been the operator, right? So we understand how that goes. We understand the variability. So we design with that in mind. And that's a big differentiator from a lot of our competitors who essentially develop something, you know, from the engineering staff that gets launched on the floor, and it's very rigid. FutureDial takes a completely different approach, and we make it configurable. I always say I want a software that fits like a glove. We shouldn't be telling our customers how to run their operation. They should be selecting how they want to run it from our software. And so we really use that with our functional test first with RADI. Now, a big differentiator in that space is a lot of the competitors went with a larger, more expensive model that maybe has more throughput, but it's not economical if you don't have that kind of volume. We went with more of a modular system, so you can put in 1 or you can put in 100, however you want to do that, but it gives you more flexibility with volume for your money. The other thing is the way we do device profiles. We don't require jigs. So our device can handle Apple or Android, and you can put an Apple in right after an Android. You don't have any kind of hardware changeover to do. And so where some of our competitors went wrong in that space is they made jigs that are very time-consuming to change, which also then costs because you have to have a sort somewhere in your process upstream. So we've moved away from that mentality in our development and tried to make it just as flexible as we understand that 4,000 different models can come in the door. We want a product that can handle that mix without any other interaction with the device. With the visual inspection, you actually hit on this in your first question. A lot of our competitors went after AI, and AI sounds really fancy, right? It sounds great on the surface, but like in your question, you have to train it, which means that if your customer or your grading standard or CTIA or whoever changes it wants to allow one more scratch on your surface, you have to run hundreds of devices through it to retrain it to accept that, versus our approach, which says you just go check a box and tell it now you can have 4 on surface AA. And so that approach is just making it flexible, making it configurable is really a differentiator that you're going to find in the market today.
Thank you. That's really helpful. And I would just say that I think that's that's consistent with any group. I mean, much of us do the same thing. I think it's always about, who you work with, the relationships, and sort of that feeling of confidence of where you come from and the kind of integrity and also the kind of knowledge that you bring to the table. So this was really fascinating. Thank you, Angel.
Well, thank you. I appreciate everybody's time for listening to this.
Yes, thank you, Angel, so much. Does anybody have any other questions for Angel? Nope. Angel, thank you so much. You've done an incredible job. I think everyone appreciated you going through the detail, and the amount of information you provided was wonderful. So,
well, thank you, and thank you for the opportunity.
Likewise. And so now Tony, are you on the line?
I am. And one point for Angel, one question, it's sort of a question. I was waiting if anybody else weighed in. But Angel, and I apologize, I did not hear clearly where you identified the new CTIA grading standard and in parallel with what the grading standards you were presenting on the screen. Are they fairly aligned, or do you expect to make changes towards what CTIA is suggesting?
No, and I do apologize. That slide was kind of fuzzy because I was trying to get so much detail in the screenshot. The CTIA standard, I think, is really going to make a splash in the market, and I say that because they have picked such big players to be heading this up, and because the market wants so badly to have some kind of a standard. So I really don't foresee us doing anything different than CTIA. In fact, the intention right now is to preload all of our automation software with a profile that is the CTIA grading, so that it could be plugged in and press go at any operation, and it's already configured for what theirs is. What I was highlighting is that if you look at their functional test criteria of what qualifies as a major or minor, you'll notice that not all possible device functions are on that list. And so we showed our planner that has 70-plus tests. That was actually just the Apple print screen. There's a different one for Android because Android does have some technology that doesn't exist on Apple devices yet, and vice versa, I should say. So what that was really showing is that even with this consistent grading standard, there are going to be functions that exist on devices that aren't listed as a requirement for testing. And the example that I gave was NFC, because not all devices in the market today have NFC technology. And so it's going to be up to CTIA when and if to add new functions or features into that grading, because if not all devices in the market have it, then how does it fall into grading, et cetera. So to answer your question, I think CTIA will be the standard. I think they're doing it right. And I think it's up for the rest of us to really follow along, but there's always going to be a gray area, I think, with some of the new features as they launch.
Thank you, Angel. And the point about that too is I know that some of the companies, even that are on the call, are looking at this will affect the yield results, the yield rates, and that affects them financially because if you decline your A grade yield rate because you're following the guidelines, it can affect you in terms of the product that you have to resell in the marketplace and so on. So I know that for everyone listening, everyone in the wireless industry, there's some concerns about the impact to the yield rates, the recovery, and the subsequent market pricing of those goods. And those are valid concerns. I didn't bring it up to address the solution, just to bring up that everyone needs to be or is already paying attention to this as it rolls out in the future.
So that is an excellent point, and that kind of dovetails with the big question of once robotics can test all these functions, what impact does it have on value? It may actually be that exact topic that starts that revolution, because while they're defining the naming logic for A, B, C, and 1 to 10, 1 through 9, I should say, 0 through 9, they haven't addressed what the value of those are. And so there's a whole secondary market that's used to an A being, a variety of things, but worth this much. And you're right, that's going to slide that scale. So somebody at some point is going to have to evaluate what that secondary market value is for each of those classifications. Right?
Well, and thank you for saying that. We're glad to bring presentations like this to everyone.